Okay, for the exercises involved, we are looking at the method of shells, and for what we have in the first problem, we have the function y is equal to the square root of x as x goes from 0 to 1. And in looking at the method of shells in determination of the volume generated about the y-axis, again, the axis of rotation is going to be apart from the variable of integration in using the method of shells. So for what we have in using the method of shells, okay, we had that v of y is equal to the integral, as in general terms x goes from a to b, and then we have 2 times pi times x, since y is equal to the square root of x. And from 0 to 1 for x, we are over in the first quadrant where x is positive, and then we have times the height, which in this case is going to be the square root of x, and again we have integrating over x. And so as x goes from 0 to 1, okay, utilizing the method of shells, okay, we have v of y is equal to the integral going from 0 to 1, and we have a 2 pi times x, and the height is just going to be the square root of x. And as we take the product, okay, with the product rule of exponents, we have x times the square root of x, leading up to where we have for v of y, okay, we have going from 0 to 1, and we have a 2 times pi times x to the 3 halves dx. And for the follow through in the determination of volume, okay, the rest is going to be using the power rule of integration. So we had the transformation of the coefficient 2 and x at 3 halves in degree to respectively be transformed to v of y is equal to 4/5 times pi times x to the 5 halves as x goes from 0 to 1, and plugging in the numbers, okay, while the lower limit 0 renders the expression negligible, is that we are able to generate and thus calculate the volume about the y-axis with the upper limit at 1 for x. And so we have for the exact value, we end up at the volume generated about the y-axis equal to 4/5 pi.